Okay, this is exercise 7.5 from the Extension 1 Year 11 textbook. It's equation of a straight line. I'm just quickly going through this. So this first here is the general form of a straight line where you've got ax plus by plus c equals 0. Just a few points to note here, that the x comes before y, and that this coefficient of the x, which is the a, we need the a here to be positive. Okay, so we don't want something like negative 2x plus 5y. If it was like that, you'd need to take everything over to the other side of the equation. So the important thing here is that the x comes first, then the y term, then the constant. And the other important thing is that the coefficient of the x is greater than 0. In other words, the coefficient of the x is positive. Okay, so coefficient of x is positive. That's what's important there. Now, this is the gradient form, or you know it as y equals mx plus b form. So we've got the general form of an equation, or the y equals mx plus b form. This is called the gradient form because when you look at it, you can clearly see exactly what the gradient of the line is. Okay. The next form of an equation is the way that you can find the equation of a line if you're given the x-intercepts and the y-intercepts. I personally do not ever use this. It's just really another formula to learn, I suppose, and the less formulas you have to learn, the better. So this intercept form of a straight line is x over a plus y over b equals 1, where a and b are the x-intercept and the y-intercepts respectively. So it's the x over the x-intercept plus the y over the y-intercept equals 1. Instead of using this, in example 3, we will look at using, instead of doing this, we'll look at using the point gradient formula instead. Okay? Now, the point gradient formula is the one that I use for every type of question. So it involves using a point and the gradient. That's why it's called the point gradient formula. And this formula is, so the equation of a straight line is given by y minus y1 equals m bracket x minus x1, where x1, y1 are the points that lie on the line with gradient m. So if you know the gradient m and you know the point x1, y1, then you can use the point gradient formula. So all you need is a point and the gradient to find the equation of a straight line using this formula. Now you can use this formula for everything, whether you're given the x and the y-intercept, whether you're given 2 points, which is what we're going to look at down here, you can always use the point gradient formula. Now there is another formula in your textbook and it's called the 2-point formula. Now I really don't use this either. The reason I don't is that you really don't want to be getting these two here mixed up, the y minus y1. Otherwise, you'll end up with, well, the wrong answer. So 2-point formula obviously uses 2 points, x1, y1 and x2, y2. So the equation of a straight line is given by y minus y1 over x minus x1 equals y2 minus y1 over x2 minus x1. Now, I don't use this. If I'm given 2 points, I use the point gradient formula. What I do is I find the gradient of the line joining the 2 points, and then I just use the point gradient formula. But if you look at the 2-point formula, the 2-point formula is actually the point gradient formula, because if we look at this here, y2 minus y1 over x2 minus x1, that actually equals m. That's the gradient formula there. So if all of that is replaced by an m and I put this x minus x1 up here on the other side, I end up with y minus y1 equals m bracket x in here, x minus x1. So I actually end up with this point gradient formula. So this 2-point formula really is the point gradient formula with the x minus x1 put down here, okay, and the m being expanded, the full formula for the gradient written over this side. So just if you are going to use this, I suppose this side is easy because it's y2 minus, it's the m, y2 minus y1 over x2 minus x1. You've just got to remember, if you are going to use this, that this is just like the point gradient formula, that it's y minus y1 over x minus x1, as opposed to y1 minus y over x1 minus x, okay? So if you do want to use this, just be careful that you think of the point gradient formula and you think that this is m, y2 minus y1 over x2 minus x1. Okay, now we're just going to do a few examples using these. And the first example is fairly straightforward. It is to find the equation of the straight line with gradient -4 and passing through the point -2, 3. So here we've got that the gradient is -4 and that the point is -2, 3. So we've got our m and we've got our x1, y1. So again, we've got a point and we've got the gradient. So we use the point gradient formula. Y minus y1 equals m, bracket x minus x1. We substitute in our point. Our y1 is 3. Our m is -4. We've got x minus, x1 is -2. And we expand all this. So this becomes x plus 2 here. And we get y minus 3 equals -4x minus 8. Now we can write it in y equals mx plus b form first. So we've got y equals -4x minus 8. If we bring this minus 3 over, it becomes minus 8 plus 3. So we've got y equals -4x minus 5. That's our gradient form, or y equals mx plus b form. Or we can also put it into general form. Now in general form it's ax plus by plus c equals 0, but the coefficient of the x has to be positive. So we're going to take everything over to the left and we will get 4x. The y will stay here, plus y. Bring the minus 5 over, which is plus 5 equals 0, and that here is general form. Okay? So you'll need to look at questions and they'll say, if they specify that you need to write your answer in general form, then you need to put it in this form, and noticing that the coefficient of the x must be positive here. Okay, our second question here is to find the equation of the straight line that passes through these 2 points. Now, as I said, I do not use the 2-point formula. I use the point gradient formula. So what I'm going to do first is we're going to work out the gradient of the line joining those 2 points. So I'm going to call this x1, y1, x2, y2. So I've got my gradient is -7 minus -3 over -4 minus 2, and we get -7 plus 3, which is -4, and -4 minus 2 is -6. Simplifying that, we get positive 2/3 because it's a negative divided by a negative. Then now we can use the point gradient formula. So part 2 of this will be to the equation of the line using the point gradient formula. Y minus y1 equals m x minus x1. Now it doesn't matter which point you use here for the x1, y1. You could use that point there or this point here. I'm going to just use the point x1, y1. So I've got y minus -3 equals, the gradient here is 2/3, and we get x minus 2. So we've got y plus 3 equals 2/3 bracket x minus 2. Now we need to get rid of this 3 down, because this 2 is on the numerator and so is the x minus 2. So I need to get rid of this divide by 3. So I will times the other side, or I'm really multiplying both sides by 3 here. So I'm going times 3 times 3, remembering that there are 2 terms on this left-hand side. So we need to multiply both those terms by 3. So we get 3y plus 9 equals 2x minus 4. And at the moment that is not in, now you would never do this one in y equals mx plus b form, okay, because it's got a 3y here. So this would automatically go straight into the general form. Now the coefficient of the x is positive over here, so we'll take everything over to the right hand side. So the 2x stays, we bring the 3y over and we get minus 3y. The minus 4 stays over here, and this 9 will go over and we'll get minus 9. So therefore the equation is 2x minus 3y minus 13 equals 0. And that is the equation of the line through those 2 points. Now, I would not use the 2-point formula for this. I think it's, otherwise it does get quite messy. So you're doing the gradient bit there, and then using the point gradient formula here. So equation of line using the point gradient formula. Okay, I think that really is the best way to go. Okay. All right, there's one more example that we're going to look at. Okay, in this example, we're asked to find the equation of the line with x-intercept 3 and y-intercept 1. Look, we can try and use that formula x over a plus y over b equals 1. So that would be x over 3 plus y over 2 equals 1. I don't use this method. I actually just will do it another method in a minute. But if you want to use this, I suppose you can, but you don't want to mess it up, okay? So now we need to get rid of the denominator. Lowest common denominator here is 6. So we're going to multiply through by 6, okay? So we're multiplying each term by 6, so we get 6x over 3 plus 6y over 2 equals 1 times 6, and that gives us 6 over 3 is 2, so we get 2x plus 6 over 2 is 3. So we get 2x plus 3y equals 6, and putting that in general form, we get 2x plus 3y minus 6 equals 0. Noticing that the coefficient of the x here is positive, so we just bring everything over to the left-hand side. Now, the other way to do this question, get a bit more room, is let's do a quick sketch. So I'm going to do this another method over here. Find the equation of the line with x-intercept 3 and y-intercept 2. So here is my line. I'll just do a quick sketch. By drawing this, sketching it out, I can quickly see that the line has got a negative gradient. So I'm going to just, by looking at it, I can just work out the gradient of that line. So it's rising up to, so first plot your x and your y-intercepts, okay? Then look at what your gradient is, okay? So your gradient is rising up to and running back minus 3. So the gradient is negative 2/3, okay? Now, we can now find the equation of the line using the point gradient formula. So I'm going to do y minus y1 equals m bracket x minus x1. Now the point that you can choose can either be the point 3, 0 or the point 0, 2. But actually, what else? You also could do this in y equals mx plus b form now if you want. I think we should do that. So I'm actually going to rub this out because we've got the gradient and we've got the y-intercept. So we can do it either way, okay? You could use point gradient formula, or we can use y equals mx plus b or gradient form. So if I go y equals mx plus b here, I've got y equals, the gradient is negative 2/3 x and the y-intercept is plus 2. But here I still need to get rid of this divide by 3 here. So I'm going to multiply through by 3. So I'm just going to make some more room here. So I'm going to multiply through by 3. So I'm going to get 3y equals minus 2x plus 6. So multiplying that by 3, this by 3, and that by 3. Taking everything over to the left, I get 2x plus 3y minus 6 equals 0, which is the same answer as I got over here. Okay? And another way we could have done this, and I'll just come over here as well, is I could have used the point gradient formula. So I could have gone y minus y1 equals m bracket x minus x1. So here my gradient I know is negative 2/3. Now my point that I use could either be the point 0,2 or the point 3,0. So I'm going to use point 0,2, the y-intercept, I suppose, and I get y minus 2 equals m bracket x minus 0. And so I get y minus 2 equals negative 2/3 x. And here I need to multiply again through by 3, and I get 3y minus 6 equals minus 2x. I just need some more room here. And then taking everything over to the left to make the coefficient of the x positive, I get 2x plus 3y minus 6 equals 0. So that's another way I could do that. And the other thing I could have done was substitute, instead of the point 0,2, I could have substituted the point 30. I'm going to do that as well so that you can see that you do get the same answer. So I'm going to use gradient is negative 2/3, and the point I'm going to use, if we look back up here, I'm going to use the x-intercept 30. So I'll just bring that down here. So the point is 30. So let's try that. Y minus y1 equals m bracket x minus x1. I'm just doing this to reassure you that no matter which point you use, you will still get the same formula. So we get y minus 3 equals m, negative 2/3, x minus 3. So we get y equals negative 2/3 x plus, just got to be careful here, plus 2. Because it's negative 2/3 times 3, the 3's cancel, and a negative times a negative is a positive. Now multiplying through by 3, we get 3y equals negative 2x plus 6. And then taking everything over to the left-hand side, we get 2x plus 3y minus 6 equals 0. Notice that is identical to all the other answers that we've got, okay? So there's many different ways you could do this, okay, but we get the same answer with all of them. Okay, I'll just set the exercise for you now from exercise 7.5. Okay, now these are the questions I would like you to do in exercise 7.5. It's question 1, B, C, D, F, G and H. Also question 2, then questions 3A and E, and questions 4, 5, 8 and 9. Okay, thank you.